Hey guys, my name is Vikas and I welcome you all to this new session organized by Java User Group Gujarat. And in our today's session, we will be going to be learning about how you can basically go and boost your application performance using the modern versions of Java. And a bit about ourselves before we go and deep dive into the session. So who we are, what we do. For the people who are joining is for the very first time, this introduction is for you. We are from Java User Group Gujarat, and we are one of the jugs across the globe. And we basically are, fostering community of Java developers in the region of Gujarat in India. And we are responsible for organizing events in regards with Java. We are spreading awareness of Java. And if you want to know more about us, and if you want to be a part of this community, then these are our social media channel handles. You can go and follow us here. Once you will go there, you will find our other links as well, like our YouTube channel link, our LinkedIn group link, our Twitter community link, our event page, everything, right? You can also go and see what are the past events we have conducted so far. So that's a bit about us. Now, a bit about me, your host. So my name is Vikas. I basically am from Gujarat, India, and I carry a 10 plus years of experience into Java backend engineering, and I'm also Gujarat Jug leader and community manager here. And yeah, apart from my professional career, I enjoy sharing my learnings and experience online through my social media handles and in the form of technical blogs. I do it on my personal website and some other popular platforms. These are my social media handles. If you want to know more about me, you can go and check it out at the rate Vikas Rajput in my Twitter and LinkedIn user IDs are same. Once you will go there, you can go and you can connect with me. You can, uh, yeah, you can check my more details there. Uh, Now it's time to welcome our speaker. So Vaibhav Choudhary is our speaker. So he's from a professional front. He is a JVM engineer at Salesforce, and he carries over 2 decades of experience. And he has worked closely with the JVM platforms team. And he is really keen about topics like garbage collection, optimization, runtime compilers, and what. Join me in welcoming Vaibhav. So Vaibhav, if you want, you can reintroduce yourself in your own words, and you can get started with the session. And yeah, the stage is yours. I'm handing over the screen to you now. Yeah, please go ahead, Vaibhav. Thank you.
Today, let's forget about the backward compatibility and let's come into the engineering world, and let's see that what you are going to miss if you are not on JDK 17 or JDK 21. In fact, JDK 23 is available, right? So you are going to miss a lot of things, and I'm going to show you like um, the articles by the Twitter and the articles by Netflix, who are on JDK 21, and they are basically explaining the whole thing, like how they have solved their recent problem by migrating on JDK 21 and what are the features they are using. Okay, so yeah, if you have any question, you have to raise it. I will not able to read to the chat, or maybe we will have in the Java we say save point. Save point means when all the thread are suspended and we can do a garbage collection run, right? So let's come to a save point where Vikas can reiterate the questions that are there into the chat, and then so you need to wait for my signal to give you the save point signal. Okay, so evolution of Java, I already discussed Java as a language and platform has evolved as per the industry change. We have a spread from the single core to the multiple core to the parallel streams to how to deal with blocking and non-blocking and all kind of things. You know most of the framework which you are seeing today actually basically backed up at the back end by Java. Okay, it is as good as that. Okay, and this is my personal view, but I still believe that Java is the only language today also exists which is so highly scalable, right? If I have seen, and we interact with so many customers, if they are not able to scale Java, they feel like it's a problem. Whereas other language, if they are not able to scale, they like say like, okay, the language is new to the market, so that's fine. I mean, so basically they don't treat Java like a language to write a hello world. Okay, so they want the serious business to be run in Java, right? And they want it to scale up to infinity. Okay, and language supports that. Language try to get all the leverages with the underlying processor, with the underlying architecture, and try to do as best as possible, right? And when generally I talk all these things, people ask me that what is the future as the future of Java, right? And I feel like I am too naive to say anything about the future of the Java. But by seeing the number of downloads and the number of usage of the Java in last 5 years, it looks like it's still going on a very high rise. Okay, so what I will tell you is that we will first discuss on the self feature, right? On the self feature means those performance which you get directly just by, say, by moving from JDK 11 to JDK 17. Okay, it's a straight thing that is related by a JDK major upgrade. Okay, you don't have to do anything. I mean, you just have to go and change your Java version and boom, that's it. I mean, your performance will be boosted. I mean, if you have your P99 and P99.99 percentiles and all those dashboards, you definitely can see uh, for good thing they spike up, and for the bad things they spike down. Okay, if it's not there, you can anytime reach to me, and we can definitely figure it out if there is a regression, right? In my history of like something like 18 to 19 years, I have like not handled more than 6 7 times when the customer have a regression with migrating to a higher Java version, right? So it's kind of magic which mostly all the time work. Okay, so any feature which is onto the JVM side, right? Like the feature like say like the garbage collector or the fix into the compilers. I'm not talking about the JavaC compiler. I'm talking about the runtime compilers. I have like 5 hour session for what is runtime compiler and how it optimizes Java code. Anytime if you guys want to have an engineering talk about the runtime, which is not basically related to Java, runtime compilers hold good for any programming language. Okay, any programming language understand that it is not I have to do 2 into X. It is always good to do X plus X, because plus operation is always costlier than a multiplication operation, right? It is all that you are doing 4 plus 5 divided by 2. It will figure it out the value and it will feed the value directly rather than keep doing these calculations. It will always understand most of the programming language that it's a dead code, right? So basically I have told you some kind of static optimizations. I have given you the example of a static optimization, right? But Java being a runtime language, it do runtime optimizations, right? And the runtime optimizations are done by the runtime compilers. Okay, so just 1 second. I think I can see unmute. Just hold on. So runtime compilers in Java are called JIT compilers. You all have heard of it, just-in-time compiler. If you come to the technical world, it is called C1 and C2 compiler, right? So C1 is a different flavor and C2 is a different flavor of compiler, which basically do is that it makes code faster and faster, and fastest when your application is at the peak performance, right? So most of the optimizations that Java do are very trivial static optimization, but most of them are runtime optimizations. Okay, we magically remove the null pointer check. We magically understand that your method is not polymorphic in nature. It's just you have not done any overrides of your method. It's just a monomorphic call. We magically figure it out that inlining this method will be very good for this kind of code, and multiple level of inlining is very good, right? So this all kind of things can be done, right? So these are the features which are on the shelf. When you are moving from JDK 11 to JDK 17, these features you will get like they say like you will get it in free. right? And there are not on the shelf feature, which are like the API features, right? So you have to make your code change. And I'm going to discuss that in detail today. Today, I will discuss like virtual threads, which are like the talk of the town. And I will discuss about few more features, right? Where you have to do the API change. And if you will done with proper honesty and with proper discipline, you will see like it's just too good actually for the performance, right? And believe me, being into the JDK team for so long, I understand that in any case, if the performance will not improve from the existing thing, or there is a backward compatibility issue, I have seen JDK team removing the features even after 2 years, right? After 2 years, the feature was working and working, and finally there was a meeting, and we said like we are removing this feature from JDK. It's the performance is not as good as the previous feature, right? There was a Graal compiler. You all guys may be knowing about the Graal compiler. Graal compiler we inbuilt into the JDK at JDK 11 timeframe, and in JDK 16 we have taken the Graal compiler out because somehow we felt that Graal compiler was not as good as compared to C1 and C2, right? The runtime compilers. So there are many decisions like this happens, and believe me that JDK team is a team which is totally non-aggressive in the features, right? They are not like, oh, some language is making features, so I should also making the features. The feature need to be there. If the feature need to be highly tested and scalable at, I mean, it's on a very high scale, then only the features are considered to be final. Okay. So before going into some of the GC features, if there is any question, I am glad to take it. Nope. All right. Then let's go to the first thing first, right? Garbage collector. I am not believing that most of the people here are expert of GC, okay, and neither am I. But what I can explain you is that garbage collector basically means that there is an automated way to clean the memory, and most of the advanced languages have garbage collector, right? I mean, the day are gone when you are actually creating memory by your own and deleting memory by your own, right? So the garbage collector is an automated memory management tool. And when we are doing this, we need to make sure of many things. So first of all, we need to make sure that the application throughput, right? The power of the application, the performance of the application is the throughput. That should be very good. Okay. We need to make sure that latency of the application, the pause time of the application should be very low, right? Uh, Companies like Amazon claims that if their application pause time is 1 second, they lose more than 30 billion of dollar. Okay. So we are talking of very highly scalable applications like Twitter and Amazon and Flipkart and Netflix, and latency becomes like the ultra low latency is what they are looking for. Okay. We are not talking even in seconds and milliseconds now. We are talking of nanoseconds, right? No one is looking for 99 percentile. People are looking for 99.999 kind of percentile, right? So if the 99.99 percentile means 99.99% time the GC pods have not crossed your desire, right? So if your desire is 1 millisecond and if the percentile is 99.99, that means 0.01% time it has crossed 1 millisecond, right? And it will send alert. Okay, it will send alert that something is not good. So you kind of think like what is the scale which we are talking on, and what is the, I mean, I basically say greediness. What is the greediness we are looking from the application, right? And I think people are delivering that kind of application, and you must be seeing around you, right? I mean, um, sometimes I tell people like look at the work like the software engineers do, right? So if you compare to any other field of application, the applications like what is like Netflix? When last time you have seen it to be going down, or a Hotstar, when you have seen last it to be going down? And those are like big applications. Even the small apps or small applications, the only application I see going down is our internal tools, right? The tools which are like customer facing, I have seen like almost every customer is maintaining a very high percentile of application to be live, right? And when you're good with the throughput and when you're good with the latency, basically for the ultra low latency application, listen me carefully, latency comes as the number one and throughput comes as the number two, right? For them, the pause time is more important rather than doing number of transactions per second. Okay. Say like any of the UI based application, take like Amazon.com. For them, the latency is much higher than throughput actually. They are perfectly fine that they are able to serve less number of customer in 1 second, but they are not fine that the customer UI is hanging, right? The UI got froze, or the page or the payment gateway got frozen, right? So that's not fine, right? And when you are satisfied with this too, you are going to satisfy your footprint, right? So footprint can be the memory footprint. I definitely need to be low, right? All the other resources, the CPU utilization need to be low. The power dissipation need to be low, right? So this, I mean, so generally GC makes a pyramid structure or a triangular structure if we are talking of 2D diagram, where we always try to get happiness of latency, throughput, and footprint, right? So everything cannot be so good. It's just like our family, right? So we will see that whatever is priority for us, and we will try to move the dot to that side. Okay, so like I have explained you, the low latency application softwares like share market, like Netflix, like Amazon, like Flipkart, these days most of the applications are low latency applications, right? They, for them, the point will be shifted to the latency, right? And less onto the throughput and less onto the footprint side, right? Whereas those applications like, say like I'm running a cron job, right? I am really not worried about the latency. So I will be looking for the throughput, right? Like if I have something to take a like physical paper and converting into a PDF. Okay, so I am looking at what is the great throughput I can get out from it. Okay, so this is where the pyramid structure lies. Now what happens that I will just take you through the Spec JBB 2015 benchmarking of JDK from JDK 8 up to 17. In fact, I had the benchmarking available for 21, but let's consider it to the 17. Spec JBB is gold standard for JDK team, right? So what is Spec JBB is actually we do all kind of involvement, like doing the transactions, creating thread pool, writing to the database, querying to the multiple database, all kind of things will be done. And then we will see that what is the throughput, what is the pause time, what is the resources that has been taken, right? And if you see the throughput from JDK 8 to JDK 17, we have almost gained like 15 to 20% of throughput, right? Which is good, right? Because which is good. I request to please mute yourself, or the owner can mute. So that's about the throughput, right? So you can see there is a definite rise into the throughput. Now let's see the latency, right? You can see there is a rise in the latency. Basically, latency is can be found out by the pause time, which is into the next slide. But we are doing good, right? So yes, you can see I have the P99 GC pause time, right? And you can see the difference from JDK 11 to JDK 17. And don't think like it's like half or it's like 1 to 10%. Okay, first of all, you need to carefully observe that it's a logarithmic scale, right? I am not talking about the linear scaling here. So you need to carefully observe the y-axis. Okay, y-axis is going logarithmic, right? So if you see the performance of GGC, right? So in JDK 11, it was 4.76 millisecond, right? And in the JDK 17 onwards, it never crossed 0.1 millisecond, right? So GGC, and that's the name called G means the last GC, guarantees that there is no pause that can happen in application which is bigger than 0.1 millisecond. Okay. So you can imagine that what is the scale we are talking. And the second good point to note, independent of the heap size, right? Let the heap to be terabyte size or let it be to zettabyte size, doesn't matter. The pause of the application, the max pause of the application can never happen more than 0.1 millisecond, right? So a lot of people ask actually, okay, so what is the trade-off, right? I mean, it is too good to sell any product into the market now. So people will ask like, okay, what is the drawback? What is the side? The side of GGC is that GGC is little higher onto the memory footprint for sure, and used to be little higher, used to be little lower onto the throughput. Okay, but in JDK 21 again we did a lot of magical changes, and that's the article I was telling you to the Netflix, right? Where like Netflix moved on to the JDK 21, and they have seen the throughput has been went so good actually from the 21 onwards, right? So these all graphs are like not like the marketing graphs; they are taken like the actual data on the spec JBB performance, right? And as I told you that memory overload will definitely increase, right? So you can see like GGC overloads are little higher than comparing to the parallel GC or G1 GC, right? So that is very much expected because when I have like 2 hours of talk on just how the algorithms and what are uh, the underlying architecture for the GGC. If you guys are interested, again, I will tell that you just reach to the Vikas and we can definitely talk like how to reach from like that 5 millisecond to 0.1 millisecond. So we have taken each parts of the pause time and like we have told, no, this need to go away. Okay. And for that, sometimes we have to do a lot of crude techniques like copying the memory into the copying the duplicate memory and a lot of other things, right? So those things many times increase the pause time, but that's expected. Everything cannot be good. Yeah. So if you're looking for a very balanced kind of garbage collector, definitely go with the older one like the G1, which is still the default in the JDK. But if you are dealing with some very low latency applications, you should definitely go and try the GGC, which is the I think in the production after JDK 15. And the guys who are on JDK 11, sorry, I don't have anything for you. Though GGC is there in JDK 11 also, but it's not production ready. So if you want to take risk, you can take the risk, but rather than taking risk, it's easier to move the application from 11 to 17. Okay, so that was my GC performance takeaway. The improvement is significant. The default garbage collector after JDK 9 became G1 and it will remain G1 till we are not able to make GGC in all the directions as good as G1, right? And believe me that we are working in that way, right? If you are running with the ultra low latency application, consider GGC, right? And the migration tips are very simple. There are few garbage collector parameters that has been removed or deprecated from the JDK 8. So when you are running your application migrating onto the higher JDK, you will just see like it will say the JVM not started. This garbage, this JVM argument not found, right? You should just go ahead, write into Google or write in ChatGPT. It will tell you what is the exact replacement for that. Go and substitute. Cakewalk. Okay. If any questions, I'm good to take. If any questions, I'm good to take.
Yeah,
If
Vaibhav,
no question, yeah.
I have a question. So when
Bharat, is it
yeah,
Bharat? Yeah,
yes,
Bharat,
I am.
please tell me.
Yeah. So question is related to the performance related things only, right? So obviously, as we are using the JDKs, we are seeing with our data and all, right? But and you are the creator of those JDKs, so have it is more important questions for you, right? how you are doing the performance testing at your end. So because obviously it is not like you are checking with the few MBs of data, right? You are checking with the GBs or TBs of data. So,
Yes,
so if you
yes.
can brief how you are testing those things, that whether everything is going good or not for the particular
Okay,
GC.
very good question. Okay, so JDK we run almost let's be into the Indian nomenclature. We run almost around 15 lakh test cases.
Oh,
And this 15 lakh test cases we have to run with multiple platform and architectural combinations, because you have Mac x64 and then you have Mac ARM 64, right? And in you Linux, you have a lot of Linux flavor, and then Windows, you have different flavors, right? So with all these combinations, what is your question is very important. So there are good amount of functional test cases, right? So functionally things should not break, right? Now, in the beginning, I asked you, right, like that. I will ask few questions back, right? So think like runtime compilers. Think like I have given you a runtime compiler, and I told you whatever the code you will give me, I will optimize. So just think like it's like a black hole, right? You throw your code, and whatever the code is that I will optimize it, and then I'll give you back, right? So can you just tell me a test case for this, for the functional test case, for the runtime compiler? Any one of you, just think.
yep.
I'll give you like 20 seconds. Anyone? Functional test case. Just I need a functional test case.
So I think well, in the current implementation we have lots of such things, right? So like I guess the streams and all are the functional kind of things only, because we are giving the few sentences and based on that it is actually creating the lots of things behind the scene.
Right. That is more of the API level. So you're kind of like partially right. So let me give you an example,
Yeah.
right? When we are creating a functional test case. So what I will do, I will say like calculate log x. Very simple. So log x with me without optimization and log x with me with optimizations, functionally both should give you the same output. Is it not so? Right?
Yeah.
So what we have done, we have created is something called uh, operation generator, right? Which keep generating lot of operations. 4 plus 3 divided by 2 minus 5, some plus sine theta plus log theta plus cos theta. And what we will do, we will pass it to the interpreter, direct interpreter, and we will see what is the output. And then we will pass it to the runtime compiler, and we will see the output. You know, we have found more than 100 bugs just because of that, because it is very good to optimize something, but after optimization you cannot be functionally broken, right? The value that comes without optimization and the value which comes with optimization need to be the same. Okay, so these are kind of functional tests. And coming back to your original question, there are a lot of functional tests written into the JDK suite. And then we write something called performance test, right? Performance test, whatever the major big player open source tools today, right? Let it be Tomcat, let it be Apache, Lucene, whatever the big players you are seeing. We actually run all the applications with a heavy workload and with a different kind of XMX, right? So what we say, like, reduce the heap, reduce the Java heap, and run this application with this load. Our performance testing say, first of all, there is a basic principle of the performance testing that in any case, the JVM should not crash. Okay, so that is what we thrive for. Number one, we will run these applications for 2 to 3 days, and we will see that JVM is not crashing even when the heap size is very less, right? And the second things where we do the performance measurement, we do runs like SpecJBB, we do runs like Lucene, and we have a lot of our own tools actually, right? Which actually measures performance and regression, performance and regression. If those tools throw away the regression, we have a massive dashboard which just say that JDK 8U21, JDK 8U22. Okay, I have just moved a minor update up. The whole dashboard will tell that which all methods have created a regression, which all methods have given a good performance. All the methods which we have created the regression, we need to go, we need to analyze, and we need to see that what we have done wrong. So there is always a buffer of like 0.5, right? So if it's like 0.5 or less than that, let's ignore that, right? But if there is a regression of 1%, we need to understand that, is it acceptable? Yes, the developer of that method or the owner of that method will say like, okay, I have done some security fixes and this was required, or something is important, perfectly fine. 1% regression, just take it, right? But if the owners don't have the exact reason that why the regression have came, he has to go back, he have to like look into his code again, and he has to fix it before it will be GA. GA is, generally general availability, right? So this kind of massive testing that can be done. And as a server side development, right, what you guys do, right? So when we write a method or when we write a function, actually it's written very generic, okay? But when you do any deployment onto the server side, actually you have to look for the optimization on that particular server, right? So API of Java can be written very good for, say, like for 6 GB of space, may not be written perfect for 6 TB of space, right? So that is where your techniques come, your optimization or your deep knowledge comes. Because maybe when I am moving the heap size from 6 GB to 6 terabyte, I need to tweak some of the parameters here and there to get the complete performance benefits. Okay. So that's like a short answer for the question.
Thanks, Vaibhav. And it was insightful. Yeah, thank you.
Thank you. Okay, so hope you have understood just like the outer surface of the garbage collector and whatever the key points. Because I am again saying you that if you guys want to go into the detail, like what are the tuning parameters or how the garbage collector behind the scene works, please feel free, and then we can have some sessions, right? So that's just for FYI. Right. Now I'm coming to a very interesting part called class data sharing, and I am very sure that most of you may not have heard of this term also. Okay. So before even starting what is class data sharing, let me show you a simple demo with class data sharing available and not available. Okay. So okay. You can see my terminal, anyone?
Yes, we can.
Right. So you can see my terminal, one terminal it's written JDK 11 and one terminal it's written JDK 21. Okay, and for the happiness, I will just write Java minus version, and it is saying JDK 11.02, and I will do Java minus version. I fooled you. So this is JDK 17. I don't want it to be JDK 17. So let's do one thing. Go to work and go to JavaTalks. I had JDK downloaded, yes. Then let's do export Java underscore home equal to open JDK and JDK 21. Here you go. Content home and then export path equal to dollar and then now let's do Java minus version. Okay, so we are on 21. Right. And what I'm going to show you, I'm going to show you running a script. I am just running a hello world for 100 times. Okay. So definitely here the Java will be taken whatever the Java set for that terminal. Okay, and let's just not run it and try to get the time it took to run this. So Mac have a very simple time command, which it can tell you all the time, user time, system time, total time. Okay, here goes JDK11. Oh, no, 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 no. No hello world is available here. Let's check it out. Okay, 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 okay. I can see a hello.java. Okay, and maybe it is looking for a class, so just make this class available. Here you go. Okay, so JDK11, hello world 100 times. As simple as that. Okay. Yeah, you can fight with me later saying that my application is not about hello world, but we will discuss that. So it has taken 14.398 seconds to run hello world for 100 times. Okay, and the user time is around 12.35 seconds, right? And the system time and the total time is actually basically kind of addition of that, but there can be overlap. I mean, I really don't want to go into the operating system details. Let's do the same work here and let's run time sh run.sh. Okay, this is JDK21. And JDK21 have finished it into 3.490 seconds. So 14.39 to 3.49, around 400% improvement, right? And I have not done anything. I have not done anything insane. What I have done is that I have just run hello world. Okay. So I understand and I respect the idea that our applications are not hello world. So it's not a benchmark that we can test and we can say like, my application will also go 410% faster. But what I'm trying to telling you that there is something that has been changed from 11 to 21, right? Now, question for you, if anyone can, you find it out. I mean, the person who don't know that, right? Just read the Java minus version thing here, that is 11. I will give you 10 seconds to read it. 4, 3, 2, 1, 0. Okay, and then the Java minus version here. I will again give you 10 seconds. Okay, 2, 1, done. Now you know that in kids there used to be give two pictures and they used to tell, okay, tell me the difference. Okay, so definitely Java version is not the question of difference. What is the difference which you have seen? Anyone? Yeah.
The minor version one.
No, no.
I could see sharing, the
Okay,
mixed
who is
mode
this
and
person?
sharing.
Yeah, is that Satish? I
Yeah,
can see your
Satya.
name.
Yeah.
Satya, yes, yes. Here you go. You figured it out the right thing, right? So you can
Yeah.
see JDK11 don't have a sharing mode and JDK21 have a sharing mode, right?
Sharing. Yeah.
And that is basically class data sharing, right? So when people have moved from 11 to 17, their application started running magically very fast in terms of startup, and they were not knowing actually why the startup became so fast. So what happens that this whole concept of class data sharing comes into the picture. What is class data sharing? I don't know. I have a skill. Okay. I can draw anything here. I can draw anything here. Yes. So what happens into the class data sharing is that this is your JVM, right? And then this is your JVM. So you have multiple JVM. Now, Java, because of the security reasons and because of the old class loader concept, right? You know the class loader of Java. That also, if you don't know, I have 2 hours of presentation just how the class loader works. So again, reach to Vikas. The class loader of the Java basically works like whenever you tell Java to get go find a class. Okay, you write a string s equal to new string. Now you have to tell Java that where is the string class. So it works on a parent delegation model, right? This is how like the Indian society works. So the kid like who is running the application, he will transfer it to something called extension class loader, and from extension class loader it goes to the bootstrap class loader, right? Bootstrap class loader is the ultimate parent, which basically holds all the JDK classes, like a string, like math classes, like all the classes belongs to Java land, right? Or Java IO. So if the class found good, as the parent will say that this class is not with me, go down, right? Then extension class loader will try to find it down to the extension level. It will say, no, this class loader is not with me. Then it will go down and it will look for your class path. You pass minus CP, or you write a jar into your running application, or you pass from the Maven and Gradle, whatever it is, right? And your jar have that class, right? So in the class path, finally you got class loader, right? So that is called user class path or user class loader, right? Finally you got the class. So always it is that first I will go and find out if there is a JDK class that exists or not, then there is extension class that exists or not, and then there is a user class exists or not. Okay, extension class has been removed in the recent JDK, but let me explain you the concept. Now what happens that class loader always do this and it loads the class, and this all behavior happens at runtime. So what we do into the class data sharing, like CDS. CDS said that whatever is the loaded class in the Java, whatever is the trusted class in the Java, I will just create a dump of that class. And when your JVM will start, I will put into the fastest memory for you. That I will take it from the operating system. Anyone who is writing note, you should go and read about mmap, mmap, right? So mmap is actually, memory map is one of the fastest way to handle the on-the-fly memory, right? So what we do is that we create some kind of dump of all the trusted class. Trusted class means not your class. Trusted class means JDK classes. And I have created a dump for that. Now, whenever that application runs or the next JVM will start, it will see, oh, this class is already available to me. Let's not go and disturb the class loader hierarchy. Let's not keep calling this. This class is available for us, just use it. Okay, so that's the beauty, is that why your startup is so fast onto the next time, right? Class is available, and just to run a hello world, you know, right? There are so many class we load it. Okay, so now the class will not get loaded by the class loader. It will be taken by the mmap, or it will be handled by the class data sharing. Okay, so that's a very simple concept. Now, how to clean this? Just 1 second. Let me get this clear all drawing. Okay, good. So that's what sharing means. And I don't know where is my JDK, how to figure it out. Let me take you to the JDK 21. And here what you do, you run a find command and try to find like star.json. No, seriously. Here you go. So you can see like there is something called classes.js, Java archive, Java shared archive. That's the full form, Java shared archive, right? If I will delete this file, what it will happen, it will become damn slow again, right? If I'll delete this file, it will become damn slow again. Or what I can do, not only deleting, I can handle this in other ways. You know, this beautiful thing can be switched off by adding a flag called -xer, -xer. This off or capital off, that is a pain in ass. I always forget that. Okay, let's try this. Okay. Let's see. Oh, sorry. Should be little slower. Should not be as good as 3 seconds. Right. So you can see that we have went from 3-second performance to 6-second straightforward, right? So that was purely because I have disabled now the class data sharing. I have disabled now the class data sharing, right? So I am saying, go man and take the class from the class loader. So you have to keep loading your classes all the time, right? And do you know, sorry, do you know that, I mean, if I'll go into the detail, it will take a lot of time, but you can definitely print like verbose. And what will happen if I'll say, this is loading all the classes. This is loading all the classes. And since Hello World is running multiple times, it may be loading it multiple times. Now what I'll do is for you is that I will remove the XR and or I will make it explicitly on. That is also, so there are 3 flavors: off, on, and auto. Okay. And now I will run this class. You may be able to see somewhere that it will say that taking from the archive. Okay. I don't, yeah, see, you can see shared object file, right? Shared object file, shared object file. Okay. So it is telling that I am reading all these guys, all these Java classes from the shared object file. Okay. That's the beauty. That's the only thing that I want to explain you. And the good news is that the class data sharing, the CDS is from long time. If you guys are on JDK 11 and still not migrated on JDK 17, and your boss is not giving you enough time to migrate, you just make the class data sharing on into the JDK 11, right? So what I can do is that even here, I can JDK 11, I can go and I can say minus X here on, right? It will make it on, right? JDK 13 timeframe, I think when we have switched this and we made it default, right? So before that, you have to go and use it because, we were waiting for like the feature to be perfectly stable. Sorry, not this. Okay. Getting back to the next point. I have explained you all the story, Xering on, off, auto, everything. I have explained you memory map. I have explained you how the different JVM instances share the class. And the great part is that you have a dynamic archiving and you have app CDS. Just looks like very complicated term, but very easy to understand. Dynamic archiving means when the JVM will shut down, it will remember what all class it has loaded in the last, and it will create the archive as per that. And app CDS means application class data sharing. Now it is not only the JVM trusted class, it is your class also, which you can give a list and you can create a CDS out of that. You will say, bro, I have like this all jars which I want to be finally loaded. These are all trusted jars. No problem. This is a TestNG jar, and this is JUnit jar, and this is Tomcat jar. These are all trusted jars. What I will do, I will create a archive from all those jars, and I can just say like, take this dump and put it with your JSA file. Okay, that's it. Okay, no class data, no class loading concept. Okay, so someone who is not using class data sharing and still on JDK 11, you must go and try it out. Okay, fine. Any questions here? I hope I have just touched the surface again, so you may have understood what is CDS. If any question, I can take it as.
So
let's move
Vaibhav,
forward.
one
Yeah.
question. So when we run our applications from IDE, can we set these parameters or flags? Then because in development mode, we run our applications multiple times, right? So it's gonna be faster, right? If we provide all the binaries or the jars that had push this into app CDS.
Yes, you can do it. You can do it from the command line also, or from the IDE.
And we run in containers, right? So will there be
Yes.
significant boost in
Yes.
there also?
My actual CDS, you just go to the YouTube channel where I have shown the CDS performance in the container itself, right? So since here there are a lot of things I am saying, but there is a talk onto the Bangalore Jug, which is just about CDS, where the class data sharing feature came just because of the container. Okay, we want to run the application startup to be fast. It has nothing to do with the peak performance. You must have figured that out. It has to do with the startup time, right? So
Right.
I have shown multiple demos in the container, Docker container, where how the CDS, we are running into the multiple container and showing the performance. So
I'll check
100%
that.
you can do it. Yes, sure. Okay. Moving to the next, that's like a very simple thing, like whenever we are going to the next cutting edge technology or bleeding edge JDK, we always support, we always extend our support, right? And we always keep taking out, like now no more Windows x64 build, Windows x86 build we make, right? So that's like gone. All the 32 bits are gone long back. Okay, so but we have started supporting ARC64, right? ARC being now heavily used into the market, and all your M1, M2 laptops and all are like ARC64 builds. Thank you. So a lot of container supports. I think the Docker containers are supported, and there are many containers which JDK support, and I was into the work where we were supporting the container, and it was a great challenge for us, because whenever you do things like parallel streaming or parallel programming, what basically we do is we go to the operating system and read the number of processor, right? And we create number of threads accordingly to that, and then we start the application. Now this whole new drama of container came in between, right? And Java was never ready for the containers. So we have to introduce a layer between, right? So now we say that whenever there is a runtime.get runtime.return processor, or you go and find out the number of processor, you need to find it out that your application is running in a container or it is running on the operating system directly. If you are running on the container, you have to respect the container boundaries. You cannot just go and fetch the details from the operating system. Maybe my operating system have 32 core processors, right? But the container have only 2 given. For that particular container, we have only taken 2 CPUs. So you cannot just go and spawn 32 threads, CPU intense thread, and you will say, okay, just let's run it. Okay. So respecting the container boundary is something which we have figured it out in JDK 10. We fixed in JDK 8 also, because a lot of customers were on JDK 8. And Java completely understands the container support, right? We even support V2, C groups V2 also. Then, we have long-term supports, like every 2 years, there is a long-term for the OpenJDK support, like JDK 11 and then 17. First, it was 3 years, like JDK 11 to 17. If you go 6 month release, it become 3 years. But now it became 2 years. So JDK 21 is a long-term support, and then 21, it will be 25, which will be a long-term support. And in between, all like 20, 23 and 24 and all those things are just for the 6 month support, right? Good to go for LTS or good to go for short-term support depends on you. Depends. There can be some feature in short term which you need it. Okay, which you need it. It can be like a drugs kind of feature for you. So you cannot just avoid it, right? So in that case, I will just go in 23 and just start using the feature, and let's wait for the 25. And 25 will come. My application is already running on 23. Less pain for me, right? And I can leverage the feature, or I can leverage the API, whatever it is. But most of the massive big applications, like even for my company, we basically go only for the LTS. We don't go for the short-term supports. Okay. And that is what the point I have written into the red. Like if you are periodically updating, right, it's perfectly fine. Like say like these guys moved a Spring Boot from JDK 8 to JDK 21 or JDK 17. That's a massive change. Spring Boot guys have done it, right? So, it broke left and right all customers. It took long time for them also. And it's not backward compatible. Now, if you go to the newer Spring Boot version, you cannot run onto the JDK 8. Okay. So I'm glad that they have taken that step sometime, but it's very good idea to migrate periodically or gradually. Okay. Depends upon your team dynamics, workload, lot of other things. Okay. I will not take any question because this was all motivational talk. API level change. Now let's go and try to understand few of the API level change. And I believe I am running out of time, and this is very common that in Jug we basically run out of time most of the time. But you guys need to tell if you have to go out. I will stop the presentation abruptly at any point of time, like exit one. Else I will keep going. So let's discuss about few of the API level changes which can bring charm in your life, right? So I'm going to definitely talk about virtual thread, and maybe virtual thread is just a talk for you if you are not on JDK 21. I am not sure that how many people here are using JDK 21. Virtual thread came in JDK 17 or 18 timeframe, but in production ready it is 21. Okay, so I will definitely show you the power of that. And more than that, basically, I want you to understand the engineering concept of multi-threading, right? So yeah, I kind of fooled Vikas saying that I will talk about all the performance optimization, this and that. But I want to take you to the virtual thread. And before that, I want you to experience that how the multi-threading works into the real life. I mean, I know these days Kubernetes and Docker and all kind of container supports hide a lot of details at the backside, but it's good to know. Whereas there are a lot of API changes also. Like, you know, in JDK 21, there is something called parallel multiply. Let me see if I have a code for you. Yeah, here we go. Big integer parallel multiplication, right? Straightforward, copy it from OpenJDK seamlessly. What it do, it creates a Fibonacci series, and multiplication, where multiplication is important for all the Instagram users. Yes, for you only multiplication. When you do image processing, heavy multiplication, right? When you are into the ML and AI, I am not talking about other parts of the AI, but when you are doing machine learning, right? Lot of multiplication. When you are doing neural network, lot of multiplication. Matrix multiplication is so common, right? In most of the algorithmic world, right? So what we did is that we took big integer, and we have created an API called parallel multiply for the big integer. This code will simply show you that how how multiply will work and how parallel multiply will work. I'm just taking the timestamp. That's it. As simple as that. Okay, this all codes are available. You can enjoy, you can dissect, you can do whatever you want to do it after. So I need to be on JDK 21 terminal because parallel multiplication is only available on JDK 21. Let's run Java C, which is also not required after JDK 11. You can directly run Java. And let's run this code. And let's see how we are leveraging parallel multiplication versus multiplication. Okay. Right. 21 second. Okay. So big decimal normal multiplication took something like 21 seconds, whereas the parallel multiplication took you something like 6 seconds, right? And I am just doing a bit counting to make sure the integrity is not broken. You remember functional test I discussed with you at the start, right? So yeah, always you have to make sure that integrity is not broken, right? You cannot just give a different output. So we are just counting the number of bits into the final data. Okay, so that's the power of parallel multiplication, and that's it. I'm not going to talk anything. You guys should go and explore the architecture. If you think you are doing a lot of matrix multiplication, or you are doing a lot of ML or image processing, those kind of things, you should consider this. But before that, you have to consider JDK 21. Okay, so that's a very simple thing. So I just gave you like one kind of kick-ass demo for API level change, right? So now let's see some of the other evolutions, which is basically virtual thread. I have done multiple talks on virtual thread, and a very small part of that is here. Right, so JDK 5, before JDK 5 world was like very good. It was normal multi-threading, right, synchronized, and just block everything and keep doing your work, and everything was good. And Then what started, human beings started becoming greedy and they want things to be very faster, right? So, and they want it to be more cleaner, and developers don't want to take the pain to write the code. So JDK guys took the pain and they have written concurrent package, right? Which basically is not the classical multi-threading model. It's not written on top of classical multi-threading model. It's a completely different thing, which is written from the base. And it has a lot of beautiful feature like parking, unparking, creating the thread pools, right? Executor framework, all those things. If you guys are using it, all you are knowing it more than me. I'm a JVM engineer. I'm not more on the API side, right? JDK 7. Okay, so we are talking about the concurrency, right? You know, there is a difference between concurrency and parallelism, right? So JDK 7 and 8 focused more onto the parallelism, right? So parallelism is kind of what? Parallelism is basically for higher CPU intense work, which is CPU intensive in nature, and just make it parallel. Like your calculations, say like I am telling you that, boss, this is an array of 10 million element. Can you just sum it, right? And if you are writing a for loop and just you are writing like sum equal to sum plus a of I, probably I will fail you into the interview, because that is the reason that why I have given you 10 millions element into the interview, not to sum into the sequential order. Okay. There is a different beauty that even writing sum is equal to sum plus a of I, these days the smart processors do a lot of work internally to even make that parallel. But on the Java level, it will just do it sequentially, right? Because it's like till I don't have a previous element available, I cannot do it in next, right? Sum is equal to available onto the previous sum value, right? So it's a block. It's called a sequential operation. Okay, so what we did into the JDK 7, that we created something called fork and join. Okay, fork and join was made for the CPU intense operations. Okay, but again, our developer community has failed to leverage fork and join. And the problem was that the fork and join, which has been given as a API, was totally mathematical in nature. You have to write too much of code actually to leverage the fork and join, right? And people in the end were like screwing up, and they were saying like the performance is much bad than the normal sequential operation. So the JDK team has decided to convert the fork and join, and they have created parallel string from that. Now you don't have to do anything. You have to just add dot parallel into your existing code, and it will automatically parallelize the code, right? How it do it is a very simple technique. You will say dot parallel dot sum. We will try to find out the number of processor for the operating system or the container, whatever I told you, we respect containers also. We will read the number we will create the number of threads, and we will just make it parallel for that many number of threads, right? And it just runs as smooth. I am again not sure that I have anything. Yeah, I have everything here. So let's see. What it is a double array. You know all the kiddo things, pi r square. If you guys have forgot, then it means you are bachelor or you don't have a kids, right? So area equal to pi r square. We are doing some calculations, and here I am doing it basically just the whatever the value coming into this area, I'm summing it all. And here I am doing it in with dot parallel. That's the only code change. This is the only code change, right? And I'm predicting the data with the same time elapsed. Now let's see. I am on JDK 2111, doesn't matter. It should be same. Okay, let's see. Seriously, it finished so fast. Not looks like we have done a great job. Let me see. The value is okay, looks like the value is too small. Right, on this too small value, I remember again to tell something to the Vikas that I have a complete demo for the parallel stream, right? And the thing is that we should not use parallel stream in many cases, right? When the number of data is less. So yes, still the number of data is less, but you can see like the parallel is kind of what man, it is like 6 times faster. I mean, I know that I have available 10 processor, but don't tell that you can make it like 10 times faster. There is some management time, right? You know, a company where managers take most of your time, right? So here also the management of the threads will take some time. Okay, yeah, as I will increase the number of data probably if I'll increase the number of, and whenever you are doing the things like parallel processing, I mean, if your array have 10 elements, seriously, you have to do parallel processing? No. I mean, managing the 10 different threads will take much, much higher time than that, right? So data should be definitely higher than a threshold value. It should be more than 1 million, 1 billion data. In fact, I have, again, I told I have a presentation and I have a recording also, which explains how to find out what should be the minimum amount of data when you should start doing parallel processing. What are the different things that you should check when you are doing parallel processing, right? Like you are doing parallel processing with primitive int, it will be very fast. But if you are doing with integer, it will not fast because integer is not hold the same way int are hold into the Java memory array, right? Int is like next, 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 next. It's a contiguous memory. Too good. I can just get all the data. Whereas integer, every integer in Java itself is a class, right? It is just thrown somewhere into the memory. Finding from one integer to next integer is not so easy. It's a cache miss. It's a cache miss. So you will see like parallel stream will give you good performance, but the performance will sucks if you will keep doing it into the non-primitive data or you are keep doing it with non-contiguous data types. Okay, let's not go into the detail. What I want to tell you that leverage these features. Okay, you should leverage the places where you can do parallel streaming in your code. Yeah.
We have a quick question. So when
Yes.
we have stream of integers, that's gonna be stream of objects, right? So the int stream that's there in the API, does it use the primitive ints?
Yes, the
internally?
int stream, yes, int stream do primitive int, right?
That's why
And if
special int
yes,
stream.
yes, then that's the region precisely what it has been created. You got it all right. Okay. So the story was not up to the parallel stream, right? So parallel stream is JDK8. You all have done and dusted with the parallel stream. Sorry, I am into the some office thing also, so I keep checking my mobile in between. So what happened that life was good. We were having like good package and good parallelism and good concurrency. Okay, and concurrency you understand, right? You have to block something and then you have to wait like multiple threads are trying to go. It's just like your toilet in your home, right? So someone need to come out, then only you can go in. So for that, actually, how we made it faster by something called future or completable future. I don't know how many of you are using it, but it's a beautiful thing, right? Where you are doing a lot of CPU intense task and suddenly some IO task came. I will say like, boss, this is IO task. Let's not thread wait for this work. Okay, let's thread not wait for this work. So what I will do, I will get rid of my thread or I will take it out. Okay, and I will use my thread into some kind of useful work. How we do this? This is a little bit complicated work. The completable future, the API. Now, going forward, we have something called virtual threads in JDK 19, which is a perfect blend of normal threading model and completable means for the blocking and as well as CPU intense, right? If you have a mix of this, now it is not the developer who have to write so much of the code. Okay, it is the JVM guys, it is like the JDK guys who have given you just have to say dot virtual, like how we have done dot parallel. Okay, so dot virtual threads, that's it. The underlying JVM will take care of all those things. It will understand it's a blocking, it's a non-blocking, it will take the thread out, it will map, it will unmap. I will show you the demo. Everything is demo, right? And definitely I will show you the trivial demos. You have to go and check it out in your real production code, right? So this is how the concurrency has evolved. right? So I will just take 3-4 more slides or maybe 10 more minutes to explain you, and then after we will close it. Okay, even I have some more slides, but we will close it. So basic, when the threading model comes, when you write a multi-threaded application, the first question comes that how many number of threads I should create. Okay, anyone know the answer for this question? I'm making an application. I'm making a like supersonic application. How many number of threads I should create? What is the parameter? How I should check that?
Yeah, it's
Yeah,
based on the task. If suppose it's a CPU, based on the CPU work, then we need to create less number of thread. And if it is IO instantive, then I need to create more number of thread.
excellent. Excellent.
And
Yes.
if it's CPU bound, then the number of cores should be equal to number of threads.
Yes. And why only that? I mean, there is a perfect formula for that, right?
Yeah,
one thing which you guys have mixed is the utilization, right? So I need to say that what is the amount of CPU utilization I need to do. In today's world where you are running into the cloud, it is insane to say that I am going to do 100% of CPU utilization. Okay. And even if you have your own physical memory, right? I really don't want to burn my CPU. Okay, so number of cores into utilization, say like you are taking 80% of utilization, that will become 0.8. Okay, it's 1 plus waiting time divided by compute time. That's as simple as that, what you guys have explained, right? If the compute time is total, right, this value will become 1, wait time will be 0. So number of threads equal to number of core into utilization, definitely that. Okay, so if you have like 10 cores, you just create 10 threads. Or I want to utilize less, maybe 8 threads or something like that. Okay. And if your waiting time is more, means if you have more IO blocked operations, you have more logging systems, you have more database interaction, you have more HTTP interaction, all are IO based, right? Number of threads will go insanely high, right? So I have given an example here that if you have a CPU intense based, see in this case, I am creating 21 number of threads for 24 core with the 80% CPU utilization. But if it is a very heavy IO based utilization, I have to create a 211 threads. You know why? The reason is that those threads will be blocked by the IO guys, right? And then I should have my number of threads ready to start doing the process, right? It is as simple as that. That's why IO bound operations will have always higher number of threads. But this all is theory. It's there are problem in this theory. Okay, it cannot be as simple to compute. Okay, but let's see that you have understood the classic threaded model, right? Now, if tomorrow someone will ask you number of thread, just write down the formula, and you can clear any interview, man. Okay, that's just a joke. Okay, so compute time, we have thousands of things over the UR. We have concurrent model, we have fork join, we have parallel streams. All are doing perfectly fine, right? So we really don't have any issue with the computation. Today you are giving me a job and you are saying I have 10 processors, use everything. I will use everything. We have just shown you parallel stream, right? I will just use everything, no issues. Okay, it becomes little complicated if I cannot keep getting replicated. I will say like, okay, can I make it 100 threads now? Can I make it 200? Can I make 1000 threads? What will happen that actually your resources will getting bottlenecked? Okay, so I will come on to that point. And the second problem is wait time. Wait time is very important. Parallel streams and all don't discuss about the wait time. Okay, it has nothing to do with the wait time. It can only do purely CPU intense job, right? And sorry, I have not shown you the JVM workload, right? So I can create more number of threads. That's a way to do that, but it's a very costly solution. Okay, threads have its own cost, right? So we have created 211 number of threads, but it will be heavy on the memory. It will be heavy onto the runtime memory. Because I have created threads, I have to manage the threads, I have to manage all the data structure of the thread, I have to manage the local registers of the thread, and there are so many things, okay? It's like all the diapers need to be managed for that thread. Okay, so here also I will show you that how the virtual threads work. Okay, so this is Little's law, just for your understanding, that if you are, say like you have 50 millisecond of your latency, right? And you are doing 200 requests, okay, per second, right? By doing 10 requests concurrently. If the requests go from 200 to 2000, what I have to do? I have to increase my concurrent request from 10 to 100, right? And then 100 to 1000 and 1000. This is what it starts, right? That how the Twitter guys started, right? They started their application small, and I don't remember, they have started on something, and later when all the big shots started coming on Twitter, they first started giving it to the more number of threads. But this all will block you one place. Okay, that's it. I mean, you cannot leverage beyond a point. Okay, so that is something which was greatly a concern, where there is a mix of CPU intense and IO block operations. And the truth of today's Docker environment or today's container environment, because everything is HTTP, everything is a database call, everything goes for a JSON APIs, there are times when we need to keep doing work into the network. Okay, so IO bond becomes very, very obvious these days. Okay, so that's why I have already explained you all these things. So we need to, we have came with a design where like it should be the older model of sequential threading structure. Okay, but it should be very fruitful even for the IO bond. Okay, so right now how we do IO bonds, we have either using something like React, or we are using something like React is like a completable future, right? What we do into the completable, you can just understand like from a restaurant kind of concept, right? So the older model, if you will take, I'm sending a waiter on a table, and you guys are seeing menu, and that waiter is standing and standing and standing, right? This is a typical IO block, right? I mean, you are just finding out the cheapest item in the menu, but the waiter, you have blocked it. Okay, whereas the good, like the completable future, how it works, that the waiter is smart enough now, it will tell you that, sir, please keep looking into the menu, I will go and serve the different table, right? And then he will come out, right? So the time he understood that there is a blocking operation, I will take my CPU work, I will take my thread work out from that. Okay, and very important for you to remember now, that it is not the same waiter which is going to serve the same table, right? Because I have unmapped that thing, right? So that waiter, which is like, say like XYZ, the XYZ can go and serve another table. And when that guy who was actually blocking, if he will call again for the operation, like his menu is ready, there can be some another thread which will go and serve it, right? So that is the model which you need to understand, right? But the only issue with the fork and join and reactive and all, like the code need to be right too complicated. You always have a way to tell that I am done with my IO work, and now you have to do a callback to the thread, right? And the second biggest challenge was that when you will go for the log, or when you will go for the thread stack, nothing will be clear to you. Okay, it's a total mess actually. Okay, because there are so many times it has done the mapping and unmapping, right? So considering all these things which I have explained you here, what we have done is that I have explained you all these things. Better you go to the slide afterward. We have preserved the TPR, right? The old threading model. Okay, but in a non-blocking way, right? So what you have to do is, now you don't have to do anything. The JVM will take care of everything. You just have to say create virtual thread. That's it. Let me show you a demo, then I will explain you. Okay, it's like as simple as that. Okay, what I'm doing is that I'm creating a lot of threads here. And you know how we do the blocking operations just by writing a thread.sleep. This is the easiest way to simulate a blocking operation, right? So first, I don't want to show you on virtual. No. Okay, first, now the non-virtual, the old thread model are called platform threads in Java. So this is the old model. What I am doing is that I am just creating a sleep. So you know all the threads which are creating is actually going for a blocking operation. Let's see the time taken by this guy. Okay. Yeah, there will be like some seconds, 20, 30 seconds. If you have a question, you can ask in 20 seconds. If you don't have, you can wait it. Very simple code, nothing fancy here. Okay. If you'll write fancy, I have a lot of codes in my Git. Actually, you can go and use it. You can go and refer it. You can go use for your own demo, whatever you want to use it. So it took 24 seconds, but the actual operation was for the 1 second, right? But what I have done that I have created so many threads that it got screwed up actually. Okay, so it is actually blocking it. Now see, now the beauty of oops. What I will do is that I will just say that get rid of all this drama and let JVM handle this work. Okay. And do the JVM is smart enough to understand this work? Okay. 1 second. In fact, I should have printed into the millisecond. It should be something more than 1 second. It will be some millisecond for the thread management, right? And this is what it is. It is just blocking the operation for 1 second. That's it, right? So what we have done is that now the JVM is handling it. It understands that I need to map, unmap, I need to map. What it will do, it knows the operating system threads. It will create so many of the JVM threads, whatever it is, and it know when I have to map one and when I have to unmap. This tension has been taken out from the developer or by the code writer. Okay. And just before going to the slide, I will show you that you can also see a carrier thread demo where what I want to show you that you can see that different virtual threads when get mapped again, it will take a different operating system thread. It will not go to the same operating system, which I explained you into the terms of the waiter, right? It is not the same waiter which is going to deliver the same table again. Okay, so let's see Java carrier thread. Right, so what I am doing, I am taking virtual thread 30, right? And you are seeing the operating system thread, which is actually a fork and join thread. They are changing, right? So first time the virtual thread 30 was mapped with the operating system number 5. It got unmapped. It again mapped back to the 4. It got unmapped. It again mapped to the 1 and then 1 and then 1. Okay. So if we keep running this code, it will be keep changing. Okay. There is no sequence about it. Since I have 10 processors, so there are like 0 to 9. Okay. Actual fork and join threads, and it will be keep changing here and there. Right. So this demo is as simple as that. Okay. Now people ask me that what is the trade-off for this? Okay. There is no trade-off this. There are few issues with the pinning of thread and when the thread exits very abruptly. But you know, we are like working in all the directions and fixing all the issue. We totally believe that virtual thread is a game changer for the next generation application. And you know, I was telling you all those Netflix article and all. First, I will tell you that Netflix. See this article. If you have time, just read this. Like how the GGC in the JDK 21, which is a generational GGC, has changed so much into the Netflix technology, right? You should go and read this article, or I can explain you sometime, someday, whenever Vikas permits us. And virtual thread Netflix article. Let me see. Yes. So they started using virtual thread, and they got an issue where they actually missed the lock, right? So they figured it out, like how to get the lock. Okay, so this article is about that. We try to give the data as best as possible about the virtual thread or about the physical thread, because the mapping data is also very important, but sometimes it can be missed, it can be lost. Okay, so this was very simple demo. Sorry if few parts you have not understood, but that's perfectly fine. I mean, I just want you to make you excited on the higher surface, and then rest, you can go deep and you can figure it out the things. Okay, so what I said into the last line is the important. Virtual threads is actually end-to-end scheduling, where the M basically are very high in number, and the virtual thread means they are very light-weighted JVM threads, right? Whereas it get maps with the operating system thread, which was the old Java thread. The old Java threading model was one-to-one mapping, right? So when old Java thread, when you used to say like, boss create 8 thread, it means it create 8 operating system thread. It go and request operating thread that create 8 threads. Okay, but it's no more now like that now. Okay, you can create millions and billions of virtual thread. JVM will take care of mapping and unmapping. Okay, already explained that mix of CPU and IO bond, lot of things. Yes, you can see the performance anytime. I mean, it is excellent. Like you can see the concurrency level we have increased from 100 to 200. Transactions per second has went double, right? From 100 to 200, it directly went from 100 to 199. Very good. But when I went from 200 number of threads to 1000 number of threads, you have seen the transactions per second remained as it is. And when it has went to 2000, actually, even the number of transactions per second have reduced down. Okay, because the thread scaling cannot be just done like this. Okay, it is not the mathematics which we are doing on the paper. Whereas with the virtual thread, you can see when it has went from 100, 200 to 1000, even the transactions per second has been went from 199 to 999. And when even we went to 2000 thread, it has went to 2000, 1996, right? So, and definitely it will have little higher CPU utilizations. That's very obvious, right? And you can see the 99 percentile, no missing. It remains same, whereas it has increased so much with the normal threading models. Okay, so this is a Spring Boot application based code. Okay, I have taken it from a Spring Boot site or somewhere. So all these IDs and frameworks, they always go and do things with the latest and the greatest JDK, right? And that is how they can provide you the best. They can provide you the best. But if your code is directly dealing with Java, it is our responsibility to do this work, right? Depends upon, are you unhappy with your performance? Okay, big companies are always unhappy actually. Okay, because they know, you know their traffic, right? Their traffic is so huge that they are kind of always unhappy and looking for always good performance. Right. So that's it from my side for this, and I had many things to cover, but let's call it a close because I have already crossed 7 minutes.
Yeah. I have a question.
Please.
With virtual threads, how many native threads will be used? Is there some mechanism, or how does it decide? Does it increase, or is it pre-decided when the JVM starts? Is it decided at that point of time, or it keeps on
Yes,
dynamically changing?
you are very much right. Like when you are doing a parallel stream, right? And my machine had 10 threads, right? I was showing you the code. My machine has 10 threads, right? In fact, I had printed somewhere the number of available processor, right? It will take all. Okay. Java will, if it is a physical box, it will just take all. If you are in a container or a Kubernetes kind of world where you are actually constraining your resources, you are saying this CPU, this Docker container or this Kate, I am only giving 2 CPU. It can maximum create 2 number of threads. I mean, I can do all those drama of round robin, but basically 2 things can only work in parallel. You got my point, right?
Yeah.
So that is how the operating system threats are getting handled. Though Intel processor have something called hyperthreading. I really don't want to go into the detail, but they claim that their one CPU can handle two parallel work, right? So that is hyperthreading, right? So considering all hyperthreading, this, that, whatever, I mean, let's take like number of available processor given as a constraint, or whatever the memory you are giving constraint to your Kubernetes management system. That is what I can leverage it. That is what the number of threads JVM will make it.
Okay. Actually, my question was about when we use virtual threads. So as we increase the number of virtual threads, it does dynamically increase the threads behind, or the native threads are pre-decided when the JVM has started, because we are using some virtual threads.
100%. The native threads will be pre-decided, and virtual threads will be just mapping and unmapping to those native threads.
Okay. Yeah, actually,
You're
other
right.
point was related to the completable future. I just wanted to make a point. Actually, completable future is based on a model, parallelism model, which is based on stages basically. There's
Okay.
something called
Yeah.
completion stage. It's you have
Yes.
stages, and you have
Yes.
where the parallelism can actually you need to sit and create a diagram how you are going to use it parallelly in your project. And then you can use it very beautifully. This completion.
Yes. You're right. So the completable future, you told it's right. It's more of a parallelism, but more than parallelism, it is for the concurrency.
Yeah.
Okay. So where like there is a mix of work, right? Concurrency is always much tougher than parallelism, right?
Actually,
Concurrency is so tough to handle compared to parallelism, right?
Actually, I had
Please.
modeled this a very similar thing. I had modeled in Java 1.4. At that time, I had modeled it for one of the prestigious client.
Uh-huh. Very nice. Very nice.
I had a scheduler which would actually where the entire input was just put it in stages. I have from a particular stage to another stage. These are my processes, and because you have mentioned the stages, I use that model and load, and accordingly multi-threading and the number of threads, how many to be created, how they have to be allocated. That was decided there.
Excellent. Excellent. You should present it actually, because
That was
I
very
mean,
old.
if it is presentable, then only.
It was done for ISRO basically, and that was
Oh,
in
perfect.
2002.
Perfect.
Java
Beautiful. It should.
1.4 we didn't have concurrency API.
Okay. Perfect.
Yeah.
So
Hey, Vaibhav, Sanjay here. So I have one question. Do we also
yeah.
compare the virtual thread performance with the Golang's Go routine? Because it looks like we are competing with Golang in this space, right?
Yes, I have seen a lot of comparison into the website space. I really have not done that. Actually, I don't know Golang, right? So, but you know, my friends who are like the Golang experts, they were saying like we are good, and I was saying like we are good, and a lot of fight in between. But there are a lot of benchmarking, I think. Okay. And you know, these benchmarkings will be limited or not to the real application, because you know it's I mean, you just think like it's an insanity, right? Some application is running on Golang, that those guys cannot make it Java application, right? Just to do a
Right,
benchmarking. It will be like
right,
more than 1 month of work. Okay.
correct.
So some itsy bitsy thing will must have been some benchmarking reports, but I am not sure that is there any real benchmark that is available into the market.
So I was also trying to learn Golang. Then I realized it's a garbage collected language, right? So Java is also garbage collected. But the benefit over there is it's struct based. So, but then I found Java is coming with its own struct based kind of approach, right? Project Valhalla, value types.
Yes,
Then
yes,
there's
yes.
not going to be any difference left with Golang and Java.
Yes, so this is how the competition keep going, right? I mean, take
Yeah.
good of any language. Okay. So Golang when started came actually, Golang was like the father of this asynchronous calling.
Yeah.
Okay, in fact, the language came into existence because it was written for an internal project, I think, for the Google, and the asynchronous calls were so tough actually to write in the Java, right? Which Golang made it very simple and it became famous. And then JDK also started taking and they started writing. Where there may be methodologies are different or architects are different. Actually, architectural design of second time is much better than first time, right? I mean, you know that what are the issues that are coming here and you can fix it on yourself.
Yeah.
Okay, so this is how the language world goes. I mean, take the good feature from everyone.
Basically, then I
Okay.
stopped learning Golang because Java is easy to write compared to Golang.
Yeah, a lot of team actually um, used Golang. I know a lot of team using Golang. Okay, but yes, what you can do it in Java, you can do it in Golang. What you can do it in Golang. If you have learned already Java, you can definitely do it in Java. True.
Right.
Okay, is Vikas still around?
Yep.
Vikas. Sorry, I have taken
Okay.
extra time.
No worries at all. We usually go over time, so it's normal for us. Because when we start going deep, time flies quickly. So, anybody else, any other question for Vaibhav? Stage is open. Unmute and you can ask your question.
I have one question, and actually
Sure.
this question was since long. So as you know that we have many JDKs, right? The Open JDKs, the AWS JDKs, Oracle JDKs, and all. So how they are mapping their features with each others? So I guess many of you have the same questions.
This is a very good question and very easy for me to reply.
Yeah.
So basically what happens, Oracle are actually basically the owners of JDK. So they make Open JDK. Okay. And now there is a Open JDK distribution that has been done by many companies, can be done by Microsoft, by Azure, by Oracle itself, by a lot of Red Hat. Okay, so what they do, they apply few patches actually, and they will do a Open JDK distribution. So it will be Red Hat's Open JDK distribution. Okay, whereas the second part is very important, that they all make a commercial JDK out of Open JDK for their own usage. Right now, say like Azure is kind of pioneer in garbage collector, right? They have this podless garbage collector from Edge, right? So they will make a sellable JDK. I mean, they sell it on a heavy cost, which will have all these features like the very good garbage collector or saving the state of the data into the JVM, right? And Oracle also creates a lot of features. So what happens that one release, two minor release, the line deviates and everyone will start making their own JDK. So they are least bothered about the Open JDK security features. The security, if you want to live with the security compliance, they will always fix into their JDK, right? And then it will take some time and it will come to Open JDK, right? So if there is a security vulnerability that Oracle found in Oracle JDK, they will fix Oracle JDK, and after some time it will be fixed in Open JDK. Okay, and which is good and bad. I mean, I feel like all are same. See, so it depends upon the hardware. If you are using the Red Hat hardware, the Red Hat Open JDK will run faster on that. Okay, so we do all these dirty tricks down. Okay, whereas one thing which I have not covered today is that you should always look for the same distribution, whatever is your platform is, right? So if you are using ARC64 as the platform, you should not download x64 JDK. It will work. There is no problem at all about it. But basically JDKs have something called intrinsic. Again, I will take some time from Vikas. So some complicated operations, say like logarithmic operations, right? So what we do, we will have a Java call and we will never do Java call. We will always say, go and do the native call. Okay. Now ARC64 will have a logarithmic native call available. Okay, and x64 will also have a logarithmic native call available. Okay, so Java just leverage that thing. Okay, that is called intrinsic. All the complex mathematical things, sine, cos, log, float, are done actually by the intrinsics, right? So you should never mess up different architecture at a higher level. Okay, x64 will not work in ARC64. Yes, it will work, but maybe it will not be performant, right? So you should be always careful in downloading the JDK. If you are just downloading for Hello World, perfectly fine. But if you are doing it for some serious work, download the same flavor. Yeah, that's a short answer.
Thanks. Thanks, Vaibhav.
Okay. That was really a very great deep dive. And I really enjoyed this whole session personally. And I really love the way you shared some insights of how JVM and JDK, world works behind the scene. Because as a Java developer, we are always working from an application point of view, but you really showed us some insights from a platform perspective. That's really great. So I think there are no more questions. So before we close, I'll share my screen and I'll talk about JavaFest. So I hope my screen is visible.
Yes.
Okay, great. So JavaFest 2024 is about to be conducted in just a month. It's just 1.5 months, 1.5 months away. 23 November, we are having JavaFest, and it will be happening at Infosys campus, Bangalore. And all the jugs around India, we all are proudly supporting JavaFest event. It's basically a community-driven event where we are bringing together all the Java developers, and we would request you to join in numbers, spread the word about JavaFest, and please be part of it, because as a Java community, we really need your big support to keep these things going and keep our ecosystem, flourishing and nourishing. So we are very much incomplete without your support. So please help spread the word. Join, be part of the event. There are some really great speakers. Keynote, sessions are going to be there, and I'm sure you will love, by being part of this event. To know more about this, you can go to the website javafest.org, and you will be able to know more details about it, like how we can book your tickets there, and other details, right? That's about it. And we are at the end of our session now. So we'll be sharing the recording of this entire session is going to be uploaded on our YouTube channel with all the sources and all the links. They are going to be part of it. We will be mentioning everything in the YouTube description section, whatever the links Vaibhav have shared, GitHub profiles where you can go and check out the code, the presentation, everything you will go and have there. Just make sure to follow us on YouTube, on our social media handles to be notified of the upcoming, videos and announcements. With that, we will say you goodbye, and we'll be meeting next time.